The James Webb Space Telescope was not supposed to see this. It was pointed at Europa for a routine atmospheric scan, a checklist item buried inside a larger observation cycle. What came back was a set of spectral lines that should not sit together in the same place. Carbon dioxide, hydrogen peroxide, organic carbon, all of them present, all of them fresh, all of them arranged in a chemical pattern that on Earth we associate with one thing only. Something eating, something breathing, something using energy and leaving a signature behind. The press release used the word habitable. The data used a different word entirely. And the people who wrote the papers know the difference between the two. That is where this story starts. Not with the announcement, with the silence around it. Because if you read the actual publications and then you read the public statements, you notice something uncomfortable. The scientists are careful. The press officers are careful. The mission language is careful. Everyone is careful in the exact way people become careful when they already know the answer and are trying to decide how to say it. The chemistry on Europa is not just consistent with habitability, it is resetting. That is the word to hold on to. Resetting. Compounds that should have annihilated each other in months are still there, still balanced, still refreshing. Geology does not do that on its own. Radiation chemistry does not do that on its own. Something is maintaining the disequilibrium. And there are only two kinds of processes in the known universe that maintain chemical disequilibrium at planetary scale for 4 billion years: volcanic and biological. Volcanic activity leaves fingerprints, isotope ratios, mineral signatures, localized heat sources that instruments can map. The Europa data does not fit that fingerprint cleanly. The chemistry is too distributed, too balanced, too regulated. It looks less like a vent and more like a metabolism. Now think about what that means. Because the public version of this story is that we are years, maybe decades from an answer. The instruments are telling a different version. The instruments are telling us the answer may already be in the data, and the only remaining question is who gets to announce it, and when, and in what language. That is not habitability. That is a discovery in progress being managed on a timeline that was chosen for us. The remaining question is institutional. Who signs off? Which agency confirms? Which nation announces? Which mission gets credit? Which budget line survives? And that is before the mechanism itself. Because to understand why this data is so hard to dismiss, you have to understand what is actually underneath that ice. Not the cartoon version, the real one. The one that has been sitting there, in the dark, doing chemistry, for longer than Earth has had continents. That is where this story stops being about a press release and starts being about a place. Europa is smaller than our moon. That is the first thing to understand, and the first thing that stops making sense once you look closer. Because inside a body smaller than the moon, there is more liquid water than exists on the entire surface of Earth. Twice as much. Every ocean, every sea, every lake, every river, every aquifer, every glacier melted down, all of it, doubled, and then poured into a shell you could fit inside our moon with room to spare. That is Europa's ocean, and it has been there, in the dark, for about 4 billion years. How is that possible on a moon that far from the sun? Two mechanisms. First, tidal flexing. Jupiter's gravity does not just hold Europa in orbit, it stretches it. Every orbit, the moon deforms slightly, and that deformation generates heat inside the rock and ice. Second, radiogenic decay in the silicate core. Slow, steady, ancient. Between them, they keep the interior warm enough that a global saltwater ocean sits under the ice, in contact with a rocky sea floor, with real pressure, real temperature gradients, and probably real hydrothermal activity. Every ingredient we associate with the origin of life on Earth is present. Water, energy, chemistry, time. Now, the ice. This is where the story gets physical. The shell above that ocean is somewhere between 15 and 25 kilometers thick. Solid water ice, hardened by cold that touches minus 170 degrees Celsius at the surface, cracked by tidal stress, scarred by radiation. It is not a lid. Think of it as a vault door, sealed, locked, older than any structure humans have ever built by a factor of 1,000,000. And whatever is inside that vault has been sealed away from the surface, from sunlight, from us, for the entire history of complex life on Earth. 10 times over. Think about that timeline. When the first single-celled organisms on Earth were still figuring out how to divide, Europa's ocean was already ancient. When dinosaurs walked, it was ancient. When the first humans stood upright, it was ancient. Whatever chemistry it started running, it never stopped. Let that sit for a second, because here is the twist inside the mechanism. The exact features that make Europa's ocean a plausible home for life are the exact features that make it nearly impossible to reach. The insulating ice keeps the water liquid. The isolating ice hides what the water contains. The stable ice preserves the biology. The thick ice prevents us from ever touching it. Everything that protects the ocean also protects it from being confirmed. The mechanism that makes life possible on Europa is the same mechanism that makes life on Europa deniable. And that is not an accident. That is the actual reason this story has stayed open for 50 years. Every mission we have designed for Europa treats the ice as an obstacle, something to look through, something to eventually drill, something to overcome. That framing is wrong. Reframe it and the whole story shifts. The ice is not an obstacle. The ice is a filter. It has been selecting for 4 billion years for whatever can survive inside a dark, salted, high-pressure ocean under 20 kilometers of frozen shielding. Whatever is down there is not fragile. It is the opposite of fragile. It is what remains after every fragile thing was eliminated by time. Now think about what that means for us, because our probes are the fragile ones. Europa's surface receives about 5.4 sieverts of radiation per day. That number needs translation. A single sievert is enough to cause acute radiation sickness in a human. 5.4 sieverts a day would kill an unshielded astronaut in about 20 minutes. And it does not stop at humans. Electronics degrade in weeks. Solar panels darken. Optics cloud. Every piece of hardware we send has to be armored, and every gram of armor is a gram we cannot spend on science. Europa Clipper is designed to survive by flying past Europa in short bursts and then retreating to safer parts of Jupiter's magnetosphere between passes. It does not stay. It cannot stay. Nothing we have built can. And this is only the surface. The cryobot concepts that would actually reach the ocean, missions like Sesame and Valkyrie, are still at technology readiness level 3 or 4. That is the engineering equivalent of a promising prototype. Not a mission, not a spacecraft, not something you can put on a rocket. The distance between concept and flight is measured in decades and billions of dollars, and no agency has committed to the full funding stack required to close that gap. Then there is planetary protection. International agreements classify Europa as a Category 3 or 4 target, which means the level of biological cleanliness required for any probe that might contact the ocean is extreme. Sterilization protocols that would gut the payload. Contamination controls that limit what instruments can even be included. The rules protecting Europa from us are also the rules preventing us from asking Europa the only question that matters. We built missions to look. We did not build missions to answer. And that is before you consider what happens when you try to scale the problem. Because scaling this, it turns out, is where the physics stops cooperating entirely. There is a comforting assumption buried in every conversation about Europa. It sounds reasonable. It sounds like engineering. It goes like this. If we can drill through 3 kilometers of Antarctic ice, we can eventually drill through 20 kilometers of European ice. Just build a bigger probe. Just give it more power. Just wait longer. This assumption is wrong. And the way it is wrong is the entire point of this chapter. Melting through 20 kilometers of ice is not 20 times harder than melting through 1 kilometer. It is categorically different. Here is why. A nuclear-powered cryobot capable of the descent needs roughly 10 kilowatts of sustained thermal power, continuously, for years. Not hours, years. That means a radioisotope source or a small fission reactor embedded in a probe, operating autonomously, in the dark, with no maintenance, no repair, no rescue, for the entire length of the descent. Every additional kilometer of ice adds more time, more heat loss, more thermal management, more structural stress, and more opportunities for a single component failure to end the mission permanently. Then there is the communication problem, and this one is worse than most people realize. Ice blocks radio, ice blocks laser. There is no wireless link from a probe under 20 kilometers of solid water ice to a lander on the surface. The only solution is a tether, a physical cable, unspooling behind the probe as it descends, carrying data upward and power downward, threading through a channel that is refreezing behind the probe at every meter. If the tether breaks, the mission is over. If the surface relay dies, the mission is over. If the probe drifts sideways more than a few meters, the mission is over. And the tether itself has to survive conditions no cable on Earth has ever operated in. Refreezing pressure, squeezing it from every direction. Radiation degrading its outer sheath. Temperature swings between the surface relay and the descent head that no polymer engineer has yet designed around. One weak link, at any depth, ends the entire program. Now the descent time itself. Estimates range from 3 years to more than 10, depending on power, ice temperature, and shell thickness. Compare that to Earth. The deepest ice core ever drilled reached about 3.4 kilometers in Antarctica over years, with a full research station, human operators, redundant supply, and the ability to fix anything that broke. Europa's shell is 5 to 8 times deeper, in vacuum, under lethal radiation, with no rescue, no repair, and a communication delay of 40 to 50 minutes each way. Every meter down multiplies the failure surface. This is not linear engineering. It is exponential exposure. And even if we solve all of it, what waits on the other side is a problem the machines cannot solve at all. Assume the probe survives. Assume the tether holds. Assume the descent works, the reactor lasts, the relay stays alive, and after roughly a decade of silent burrowing through ancient ice, an instrument package finally breaks through into liquid water. What happens next is the part of the story where the engineering ends and the biology begins. And the biology is harder than the engineering. Here is the closest analogue we have on Earth. Deep-sea hydrothermal vents. Cracks in the ocean floor where superheated water, rich in dissolved minerals, meets cold seawater and creates chemical gradients
that support entire ecosystems without sunlight. Tube worms, bacteria, archaea, whole food webs powered by chemistry instead of photosynthesis. This is the model. This is what we expect Europa's seafloor might look like, if it has hydrothermal activity at all. And there is real evidence that it might. Tidal heating alone should drive some vent activity. The chemistry we see at the surface is consistent with water-rock interaction below.
Now think about what that means. Because Earth's vent ecosystems have been evolving for maybe 500 million years in their current form, Europa's, if they exist, have been evolving for 4 billion. That is roughly 10 times longer than complex life has existed on Earth. Whatever is down there is not primitive because it lives in the dark. It is not simple because it evolved without sunlight. It is parallel. It shares no ancestor with anything we know. It uses no code we can predict. It may not even be built from the same molecular alphabet. And here is the human consequence. We do not have instruments that can reliably distinguish Europan biology from Earth-derived contamination we bring with us. Every sterilization protocol reduces contamination. None of them eliminate it. If we drop a probe into that ocean and it detects organic molecules, we cannot be certain those molecules were not hitchhikers from Cape Canaveral. First contact and first contamination may be the same event. The moment we confirm it, we compromise it. The moment we touch it, we may end the only clean measurement humanity will ever get. That is not a technology problem. That is a physics of information problem. You cannot observe a pristine ecosystem by introducing a foreign object into it. And this is only the second hardest problem in the way. Because before the biology, before the ice, before any of this happens, someone has to actually fund the mission. And that is where the whole story stops moving. Here is the mission architecture in the plainest terms. Europa Clipper, launched October 2024, arrives at Jupiter in 2030. Flyby mission only. It will make roughly 50 close passes of Europa, mapping the surface, sampling any plume material it can catch, characterizing the ice and the ocean beneath it. It will not land. It cannot land. It was never designed to. JUICE, the European counterpart, launched 2023, arrives 2031. Its primary target is Ganymede. Europa gets 2 flybys. 2. That is the entire fleet, 2 spacecraft. Neither touches the surface, neither reaches the ocean. Both were funded, designed, and launched over a combined 30 years of institutional effort. And once they arrive, their science phases last only a few years each before power, fuel, and radiation damage end the missions. Now the mission that would actually answer the question. A Europa lander was formally proposed. It was studied, scoped, and priced. It was defunded. Not delayed, defunded. There is currently no confirmed launch date for any surface mission to Europa from any space agency on Earth. Beyond that, the Cryobot mission, the one that would actually reach the ocean, does not exist as a funded flight program anywhere. It exists in white papers, in concept studies, in graduate theses, not in budgets. Do the math. If we started full funding on a Cryobot program today, realistic timelines put a launch in the 2040s and an ocean contact in the 2050s or 2060s. The gap between "we might have found life" and "we can confirm it" is not 10 years. On current trajectories, it is 40 to 60. That is a full human generation. Children not yet born will be middle-aged before the ice is broken. The scientists who first proposed a Cryobot mission in the 1990s are already retired. The scientists proposing it now will be retired before it launches. The scientists who will actually receive the data are, statistically, undergraduates today, or in high school, or not yet in school at all. That is the real timeline of this discovery, not a mission plan. A relay across 3 human generations. Compare that to Apollo. Kennedy's speech was 1961. Armstrong walked on the moon in 1969. 8 years. From political commitment to boots on another world. Europa Clipper took 25 years from initial proposal to launch for a mission that will not touch the ice. We have not gotten faster. We have gotten slower. Cheaper spacecraft, better instruments, more capable software, and somehow the timeline for answering the biggest question in the history of biology keeps stretching further into the future. Why? Not because the science is impossible, not because the engineering cannot be solved. The delay is not scientific. The delay is chosen. And once you understand who benefits from the delay and how the language around this mission is engineered, the whole story rearranges itself. Follow the language. That is the instruction. Because the words agencies use around Europa are not accidental. They are chosen. And the choices tell you something the press releases will not. Start with planetary protection. Under international treaty, specifically the Outer Space Treaty of 1967 and the COSPAR planetary protection guidelines that implement it, the confirmed discovery of extraterrestrial life triggers obligations no space agency wants to activate on a schedule they do not control. Containment protocols, sample return restrictions, mission redesigns, international consultation. Legal frameworks that have never been tested in a real scenario. The moment life is confirmed, the exploration phase of Europa ends and the containment phase begins. Every mission after that gets harder, slower, and more expensive. The current framing, potentially habitable, keeps the exploration phase alive. Confirmed life would end it. Now the funding incentive. This one is uncomfortable but real. Space agencies compete for budget. Missions compete for attention. A destination described as one of the most promising places in the solar system for life is a destination that keeps getting new missions funded. A destination where life has already been confirmed is a destination where the next mission has to justify itself against a much harder question. What now? Ongoing ambiguity is institutionally more useful than resolution. That is not a conspiracy. That is how budgets work. Then there is public psychology. The announcement of extraterrestrial life, even microbial, is a one-way door for civilization. Religion, philosophy, politics, public trust in science. None of it comes back unchanged. No press officer wants to be the person who opens that door on a Tuesday afternoon while nothing else is happening. There is no protocol for the day after the announcement. There is no rehearsal, and the agencies know it. Here is what I am not saying. I am not saying scientists are lying. They are not. The papers are honest. The data is public. The instruments are doing their jobs. I am not saying there is a cover-up. There is not. What there is a slow release strategy, a managed pace, a language of hedging that keeps the discovery moving forward at a speed institutions can handle, rather than the speed the data would otherwise force. The gap between what the instruments are showing and what the public is being told is not a lie. It is a translation, engineered for stability. And the reason it needs to be engineered for stability is that the implication of what is under that ice is bigger than Europa. It is bigger than Jupiter. It is bigger than anything we are prepared to say out loud. Europa was never the real story. That is the sentence to hold on to, because if life exists in Europa's ocean, it does not exist only there. Enceladus, Saturn's moon, has confirmed plumes containing organic molecules and evidence of hydrothermal activity. Titan has a subsurface water ocean and a surface chemistry unlike anywhere else in the solar system. Ganymede has more liquid water than Europa. Callisto probably does too. Beyond our system, every survey of exoplanets adds more candidates. Subsurface oceans may be one of the most common environments in the universe. Not rare, default. Now think about what that means. Because for most of human history, the question about life beyond Earth has been a question about probability. Are we alone? The Europa data does not just answer that question, it reframes it. If life exists in Europa's ocean, then the ingredients we thought were special, liquid water, energy, chemistry, time, are not special at all. They are ordinary. And if life is ordinary, then the silence of the sky becomes much harder to explain. This is the Fermi paradox, named for the physicist Enrico Fermi, who asked in 1950 a simple question. If life is common and technological civilizations should therefore also be common, where is everyone? The universe is old. Older civilizations should have had time to spread, to signal, to leave evidence. We see none of it. Silence. The comfortable interpretation of this silence has always been that life is rare. Europa breaks that interpretation. Because if life is common and civilizations are still absent, then something is removing them. Something is filtering them out. And that filter is not behind us. It is ahead of us. That is the harder implication, not that we are alone, that we are not. And the reason the sky is silent is that intelligent species do not last long enough to be heard. Scientists call this the Great Filter. Somewhere between the emergence of life and the emergence of an interstellar civilization, something almost always fails. The question is where? If the filter is behind us, at abiogenesis, or at multicellular life, or at intelligence, then we are the survivors of an improbable climb. If Europa has life, that possibility narrows. The filter moves forward, toward us. Every prior expansion of the human frame has shrunk our centrality. Copernicus moved us away from the center of the universe. Darwin moved us out of the center of creation. Exoplanets moved us out of the center of planetary possibility. Europa's confirmation would move us out of the last remaining privileged category, the place where life happened. After that, there is no next reduction. There is only the question of what comes after us and how much time we have before whatever filtered out the others reaches us. That is not a science question. That is the verdict this whole story has been building toward. Come back to the beginning. The spectral lines from the James Webb Space Telescope. Carbon dioxide, hydrogen peroxide, organic carbon. Sitting together on a moon they should not be sitting together on, in proportions that keep resetting, in a place that has been dark and sealed for 4 billion years. Those lines were not the start of the discovery. They were the moment the discovery stopped being deniable internally and started being managed externally. Consolidate what you now know. The chemistry is already anomalous. The mechanism is already understood. The ocean is real, twice the volume of Earth's, in contact with a rocky floor, warmed by tidal flexing and radiogenic decay. And it has been running its chemistry undisturbed for the entire history of complex life on this planet. The mission architecture is already inadequate. Europa Clipper and JUICE will not touch the ice. The lander is defunded. The cryobot does not exist as a real program. The institutional messaging is already hedged, in language chosen by people who understand exactly what they are hedging around. And the civilizational implication is already too large for any single agency to package on a Tuesday morning. Every one of these facts is public. Every one is verifiable. Every one is in the record. What is not in the record is the connection between them. That connection is what this video was for. The headline you have been reading, New Evidence of Life on Europa, is not a headline about the future. It is a headline about a decision that has already been made about what you get to know and when and in what order. That decision was not made maliciously. It was made cautiously by people who understand what happens the day after. But it was still made, and you were not consulted. Here is the narrow hope. The truth still leaks. It always does. The instruments do not lie. The papers get published. The data lives in archives that anyone can query, and the pattern is now visible to anyone willing to read past the press release. The announcement, when it comes, will not feel like a victory. It will feel like a confirmation of something the careful readers already suspected. And the careful readers are you now. Something under that ice has been waiting 4 billion years. It did not wait for us. It does not need us. We are not the ones who get to decide when the waiting ends. We are only the ones who get to decide whether we were paying attention when it did.